Okay, we are on. So some of y'all asked me about the splitting pattern for cis and trans hydrogens, how we figure that out with NMR. Well, I've messed up the recording once, so I'm going to kind of speed through it again. We know that typically, let's say we had this hydrogen and then hydrogen, hydrogen here that you see on the right, and these are just chlorine atoms. They're just something that's not hydrogen. You'll know that it will couple, this hydrogen will couple with those two to form a triplet, right? Because two neighbors, n plus one makes three. So we have a triplet. And we know that the two equivalent hydrogens would couple with the singular neighbor to make a doublet, right? This is basic NMR. Both of them will do it. So you'd have an integration of two versus an integration of one, but the splitting pattern would be a doublet. And this is all stuff we've learned, y'all have learned before in the basic NMR. However, what makes this here so special is the presence of this, whoops, actually this will be good, is the presence of this double bond, which I've drawn here in pink. And now you'll have where hydrogen A, if it couples with the cis hydrogen, it'll produce one splitting, whereas coupling with the trans hydrogen is a separate splitting because they are two adjacent neighbors, but they are not equivalent hydrogens. Hydrogens B and hydrogen C are not equivalent. They are in different environments relative to like the R group or to the proton A. So how do we interpret what the data is? Well, what you'll see is you'll see one initial splitting where, let's just say you have the one peak and then you have, let's do a different color than red. I don't like that. You have one peak and then you have the next peak, right? It's a simple doublet. That's coupling from one hydrogen. Then when you couple with the next hydrogen, imagine that you split that peak into two. You kind of down the middle. You have this peak split into two and this peak split into two. So taking all that mess out, you pretty much had one peak and one peak, and then they were split into two. It was doublet, which was then split again into a doublet. This is known as a doublet of doublets. And based on how wide and far apart they are, you can know which one is coupled to which. Like you can look at the difference between, if you look at the difference between the initial split, you can figure out whether that is by the J value, whether it's one hydrogen. And then by the second split, the miniature split in between, that coupling you can find out which is due to the other proton, whether it's hydrogen B or hydrogen C. And that value is known as the J value. And as far as y'all's certain instance goes, you'll have a certain product. In your case, you'll only have hydrogen, you'll have to have them only cis or only trans, right? So since they're only cis or only trans, those are the only two options you'll have. You'll either have a splitting pattern, don't mind the noise behind me. You'll either have a splitting pattern with, let's draw this a little better, with the distance being the J value for the trans. I know it looks like frans, but it says trans. Or you'll have a splitting pattern where the J value is for the cis. So what you need to do in your assignment is, first of all, find those hydrogens. You know, there's going to be coupling one way and there's going to be coupling the other way, right? So you'll have to find those, which will probably produce your doublet of doublets. And you'll have to find that J value, that wideness. If there's only one product, you'll see a 1 J value, and it'll be either for cis or for trans. And if, as you can see, for trans products, it's usually I believe the range is actually it's here at the top. If we just scroll, I know I'm using a web page. It's not. It's Kim Libertex. So you can actually come and look at this. This will be great for your report as well. Let me just clear all my drawings. And you can find out that typically your vanillic trans will have a J value of 1118 hertz, measuring the difference, or it'll have, or if they're cis, they'll have a difference of 6 to 15, a lower coupling value. And you see this coupling here is kind of always constant and everything, etc. And also there's adjacent ones which you won't have to deal with in your specific one, but it's still good to be aware of that. So based on these two values here and the J value of your vinyl hydrogens, you can use the NMR to identify whether or not your sample has the cis product or trans product. So this, I hope this answers y'all's questions. If not, you can come look at this. The key word is doublet of doublets or just reciprocal coupling. Either way, but this is the kind of stuff that explains how NMR can tell us whether we have a cis product, a trans product, or both. If we have a mixture of both, I mean, it's usually you can really can't tell one from the other, but you can find ways to analyze it. So anyway, I hope this answers the questions that some of y'all have been asking me. Let me stop share and I'll end the video.